Products from stingless bees, we're talking their honey, their propolis, their pollen, they've become incredibly popular, and for good reason. People love them for their unique health properties. But this boom in popularity brings up a really big question, not just for scientists, but for all of us. How do we really know that what's on the label is what's actually in the jar? How can we be sure about its quality, its authenticity, and maybe most importantly, its safety? Well, it turns out it's a pretty complex puzzle that science is working hard to solve right now.
See, the thing about products from stingless bees is that they are not like the stuff you get from your average honeybee. Not at all. They are way more complex. And that complexity is what makes them so valuable. But it's also what makes them incredibly difficult to analyze. Their chemical makeup can change based on the flower, the region, even the specific species of.
So how do scientists actually peek inside these complex natural products? Well, they have a really powerful set of tools that lets them see a product's true identity, what you might call its unique chemical fingerprint.
Okay, the main tool in their toolkit is something called analytical spectroscopy. Now, that sounds complicated, but here's the basic idea. Scientists shine a type of light through a sample. By looking at how that light is absorbed or reflected, they can identify pretty much every single compound inside. It's a brilliant way to get a complete chemical picture without destroying the sample.
But here's the catch. You can't just take a spoonful of honey and pop it into one of these super high-tech machines. The raw product is this complex mixture, what scientists call a matrix. Trying to analyze it directly would be like trying to identify a single herb in a really murky soup. All the other ingredients just get in the way. So, you've got to clean it up first.
And that brings us to this crucial and honestly often overlooked step in the whole journey, sample preparation. This is the critical link between getting a sample from the hive and actually analyzing it. And trust me, this is where the real magic and the real challenge happens.
And what's so fascinating is that there isn't just one single recipe for preparing these samples. Nope. Each product, honey, propolis, and pollen, is so different from the others that it needs its own unique protocol, its own recipe, just to get it ready for analysis.
Just take a look at this table. It shows you just how different these processes are. For honey, it's often about dilution. But then you look at propolis, which is this resinous, sticky substance, you have to use solvents to pull out the important compounds. And with pollen, it might need to be dried and then processed with special green solvents. Each one has its own unique set of challenges.
Let's just zoom in on honey for a second. If a scientist wants to do a general analysis, they might just need to dilute it with some water. Simple enough. But if they're looking for something really specific, like trace metals, they need a much more aggressive approach, using powerful acids to break everything down. So the method totally depends on the question they're trying to answer.
Now, propolis, that's a completely different beast. It's this sticky, waxy resin, right? So the main technique is to dissolve it, usually with ethanol. To speed that process up, labs will often use ultrasound waves to literally shake the valuable compounds loose. After that, they filter out all the solid gunk, leaving a nice, clear liquid that's finally ready for testing. Okay, so we've just seen a couple of very different recipes for getting samples ready. Now I want you to imagine every single lab around the world using a slightly different version of those recipes. You can probably see where this is going. It creates a massive problem for the entire scientific community. There's no single agreed-upon rulebook.
This quote from the research really just says it all perfectly. There are no universal standards. And what that means is a lab in Brazil might prepare a sample one way, while a lab in Malaysia does it another way. And they could get different results from the exact same product. It makes comparing studies and verifying quality incredibly difficult.
And the impact of this is huge. Without standards, the results are all over the place, which makes it really hard to build consumer confidence or even check for dangerous things like pesticides. But with universal standards, suddenly results become comparable, research can move so much faster, and we can all have a lot more trust in the final product.
But the story definitely doesn't end there, because scientists aren't just trying to standardize the old methods, they're actually inventing brand new ones that are not only better, but also a whole lot kinder to our planet.
And this is where the future gets really exciting. Researchers are looking into green solvents that are less toxic and way more sustainable. Get this, they're even experimenting with using things you'd never expect, like honey, brandy, and mead, to extract compounds from propolis. The goal here isn't just to find a standard, it's to find a better standard, one that's effective, reproducible, and eco-friendly.
And it's not just about chemistry either. It's also about computing power.
Scientists are using a field called chemometrics, which is basically just a fancy term for advanced data analysis and AI, to find hidden patterns in all this data. This powerful software can sometimes make up for a less than perfect sample preparation, which allows for quicker, greener, and ultimately smarter analysis.
So really, it all comes back to this one question. From the hive to the lab, all the way to the shelf, the journey of these amazing products relies on science that we can actually trust. Creating a universal recipe book for scientists is the absolute key to ensuring quality, safety, and authenticity, and building the confidence we all deserve to have in the products we value so much.